Hello and welcome to another edition of James Chris Science Videos, where today we're looking at the Common Entrance syllabus of extracting metals and how to do this from their ores. So to start with, here are a selection of metals that we use every day. You can probably name most of them. We'll come to that at the end if you can't. But these are how you find most metals in the ground. You find them generally in the form of rocks. The three rocks that we need to know about for common entrance are bauxite, hematite, and, here it comes, malachite. Of those, can you guess which metal you think comes from each of them? And it isn't necessarily obvious. Here's a clue for hematite, it's magnetic. Here's a clue for the malachite. If you think of old buildings such as this in London, one of the towns, that's what it originally looked like, and this is what it looks like now. Bauxite is definitely much harder. So you'll find that most metals are found as ores in that rock type. The first one, bauxite, is aluminium oxide, formula Al2O3. So that's got 2 atoms of aluminium, 3 of oxygen, making it a compound. Hematite is iron oxide, malachite is copper carbonate. In ores, you find them concentrated in these forms. So we need to extract them and get them out of the rock into their singular form. You can find some metals underground that aren't reacted. Gold being a great example. You find little nuggets of pure gold. That is due to it not being reactive enough to react with some of the things around. So, what to do? First of all, here is a little sentence that you need to write down somewhere. Can you just fill in the words that fit into each of those as you go through the text? Underneath that, there is also a table. And again, just fill that out onto a sheet of paper so that you've got the name of the metal, the name of the ore, and the compound. So, how to react to, how to get it from its ore and what to do. To do that, you need to have understanding of the Reactivity Series. Most of you covered this in lessons. This is just an example of one. And you can see I've got potassium, sodium, aluminium, carbon, zinc, iron, copper, silver, and gold. And you notice that I've highlighted carbon in a different colour. You could probably work out why. What does this mean? Well, it means that potassium is more reactive with sodium, and therefore it can take things away from sodium. We call that a displacement reaction. Those two at the bottom you can find straight underground. Those two need to be used a slightly different method. We're going to talk about that a bit later. So, here are some examples of some displacement reactions just to get you used again to the displacement reactions reactivity series. And you'll notice that the last one you cannot react, and you should be able to answer why. So we're not going to do that at the moment. So how is it done? You take your reactivity series and you use something above it. So if I want to use iron, and I want to get iron from iron oxide, from hematite, I need to use zinc, carbon, aluminium, magnesium, sodium, or potassium, or any of the other reactive metals. The problem you've got is that some of those are more expensive than iron. So if I was to use sodium or potassium, which are more expensive metals, then I'd be losing money to make my metal. The only element that is cheap enough to use is carbon, and you find that in coal, dug up from the ground. So we tend to use carbon in order to get our metals from the ores. There we go, carbon's in twice, we need to change that. So, what do we need to do? Here's an example of the materials that we do use. We use something called a blast furnace. Now, we did cover this, and I hope you kind of remember how this works. So into this goes your iron ore, your coke, which is your carbon, and we put some limestone in to get rid of some of the impurities. We then superheat it, and we get this reaction. The iron oxide plus carbon goes to iron plus carbon dioxide, and it is a reduction, which means that it is a loss of oxygen. At the bottom, you get your molten iron that comes out, And at the top you get some molten slag, which is used usually to make roads. It's part of the bitumen that's used to make roads. Your hot waste gases come out will be carbon dioxide. That's gone through there. Here are some examples of ones at Port Talbot in Wales, which is still extracting iron today. Okay, so now we've got our iron and copper from using carbon to extract it using displacement. What do I do with the ones above it? So my aluminium, my magnesium, my potassium and sodium. Well, for this, the only way you can do it is to use something called electrolysis. Now, they don't go into detail on electrolysis common entrance, but to put it into short, what you can do is through a solution of a salt of that. So, for example, you take aluminium oxide and you either dissolve it or you melt it. If you pass electricity through that, then at the end of both terminals, the metal or non-metal will collect. So you pass electricity through at high voltage, then at one electrode you would find aluminium forming, at the other you would get bubbles of oxygen. And so that's a more expensive way of doing it, which is why aluminium tends to be more expensive than iron. Thank you. Goodbye.